Might as well not even do it.
Yeah.
Good afternoon. Today in Miss McGee's class we will be learning about the PRZs. That can mean anything from pretty rogue zebras to pretty rapid zebras. Okay.
It's 10:30 by the way.
Okay, all right, so PRZs, thank you, Mary, are not pretty rogue zebras, but in fact, they are possible, rational, yes, zeros. So we're going to take these polynomials that we wouldn't normally be able to factor. We're going to find ways to factor them because we're good like that. All right, so what does, that's a good question. What does rational mean?
It's like a whole number.
It's divisible.
That's negative and positive. It's not ongoing. It's not.
That's right, that's right. It can be expressed as a fraction or decimal, and the decimal would terminate or repeat or have some type of pattern to it, okay? So numbers like the square root of 2, pi, those are irrational numbers, okay? But, so we're talking about any number that is a real number that is rational, that terminates or repeats, okay?
12.2.
That's rational, yep, yep. All right, so, or any whole number, or any, all that are rational numbers. We're not talking about imaginary numbers.
So any number on the x-axis.
Well, square root of 2 is not on, it is on the x-axis. I mean, you could have an approximation for it.
Wait, so what was it?
So irrational, to understand rational, it's easier to understand irrational first. So irrational is a decimal that repeats, or that does not repeat and does not stop and goes on forever. There's no pattern to it like pi, right? You would have to just memorize out to a whatever place on pi and it never stops. Rational means that when you write it as a decimal, either the decimal stops at a certain point or it starts to repeat a pattern, okay? 2/3, 0.66666 repeating, right? So that's rational. Does that make sense? Okay. But we're delving way too deep. That's just, yeah.
Wait, so if there's no pattern to pi, how do we create new pi numbers?
We don't create new pi numbers. Pi is always the same number.
No, but like, how do we go further along with that?
Like it's like, isn't it like 7 divided by something? Like 20 divided by something?
It's actually the ratio of the PRZs. I'm going to take this polynomial. Let me say, this is kind of where we bring everything together. And this is always a last-ditch thing, the PRZ. Let me use the example that I used this. All right, let's say I have 2x to the third minus 3x squared minus 5x minus 12. Okay, here's my polynomial. If I just gave you that and I asked you to find the zeros algebraically, would you know what to do?
Absolutely.
You could try. The only thing you could do at this point would be to group it, if it would group. And when you look, it's not going to group, right? Because I can take an x out of the first two. I can't take anything out of the second two. They're not going to match. So it's not going to group. So I have two options. I can figure out algebraically or I can graph. And I don't want to graph. I'm going to show you how to do it algebraically. Well, and so that's exactly what we're going to do. But instead of guessing random numbers to try, I'm going to show you how to find a list of numbers. It's not quadratic. All right, so to find our possibilities.
Oh, yeah,
it is a cubic. It is a cubic. All right, so I should have how many zeros when I solve? 3, right? 3 because it's a cubic. And maybe they're not, that's exactly right. 2 turning points, but 3 zeros. No more than 3 zeros. Okay, so here's what I want to do. I'm going to list my possibilities, and then I'll start checking to see which one it might be. So to do this, I find the factors of the constant divided by factors of the leading coefficient. So I guess my first question to you would be, What are the factors of the constant? Let's put them in order, and I'm going to do plus or minus because they could be negative or positive. 1, 2, 3, 4, 6. Does everybody see where those numbers are coming from? Okay. Well, numbers are going 12. That's exactly right. How about factors of 2? So here's my challenge. I have to make a list of all the different numbers, all the different fractions that I can make, taking the factors of the 12 divided by the factors of 2. So what I always tell students to do is set it up like this. Take all these numbers, divide them by the first one. Then take all those numbers and divide them by the second one. If you had another one, you would take all those numbers. Now, you don't need to include repeats, okay? So if anything repeats, and it will, you don't have to include them. So in this case, the PRZs would be, well, if I take all these numbers and divide them by first one, they'll be themselves, right? So I can just copy that list for this first little set. 3, 4, 6, and 12. And now I need to take all of them and divide them by what? 2, right? So I'm going to do 1/2. What's 2 divided by 2? That's already on there. Don't repeat it. 3/2. 4 divided by 2 is, that's already on there. 6 divided by 2 is, that's already on there. And 12 divided by 2, that's already on there.
So you only have negative 1/2. So positive negative 1/2.
From that second one, yep. Okay. All right, so the point of this is because, and several of you noticed on that homework problem we were just working that, hey, I could just start checking synthetically to see which one gave me a 0 remainder, and you're absolutely right. But this gives us a starting point. This gives us some points of which to try to see which one might work. So now we are at a guess and check kind of dilemma here. Okay.
You have to include the positive and the negative?
Yes.
Are you kidding?
But watch how quick, when you do synthetic, and if you're good with synthetic, this is a cinch, okay? So I'm going to start with 1. My goal here is to find a factor. That's what I'm looking for. I'm looking for a factor so that I can factor and find the zeros. So,
Do you do positive one or negative?
it doesn't take as long as you think.
If it's the very last factor, we have to do the 16.
We have to do it for each thing.
Does that one work? Why?
Because that's
It has a remainder. Factors will not have a remainder. So now let's try -1. And I'm doing all this intentionally to show you, but I will show you a little shortcut in choosing which factor. I hope some of you already know. -5, 5, 0, 0, 12.
Is it the median?
Is it what?
Is it the median? Right. Something that's going to subtract out the 12.
All right, somebody, how about this half of the room try 2, that half of the room try -2, I'll try 3. Let's see if we can get to it.
So which one else done?
2. -2 does not.
Negative 2 doesn't work. You said negative
3 doesn't work.
on the board.
I'm just going in order. You don't have to go in order. That's just the way I do it.
Wait, so there's no way to like look at it and tell and just check your work and do everything. Wait, did I do something wrong? Just like,
Oh, I did something wrong here. I was going to say, I was pretty sure the factor was either 3 or negative 3.
Then how do you know that though?
All right, watch what happens whenever I do it. 2, 6, 3, 9, 4, 12. Yes.
It's not 12.
Yeah, I was like,
All right, so this one works.
how did you get to?
Did you just like take what is the factor of the last number?
What's the equation? Give me the equation again.
2x to the third minus 3x squared.
Slower.
3x to the third
Minus.
3x squared minus 5x minus 12. Oh,
What's a good choice for me to start at? 3.
So if you put
X-intercept.
in find the-
Because remember the relationship between x-intercept and 0. I mean, between factor and 0.
Was that working like 100% of the time?
Okay, but I want to see you plugging in. Like, I want to see you, like, this will give you a starting point. You can't always tell from here. Sometimes they're 1/2 or 2/3. But, well, I guess you could because you could calculate it. But it would give me something where I could just try 3 and go, got it.
wait, so aren't there 3 zeros though?
So how do we find the rest? Because Eliza makes a good point, weren't you? 3, okay? So watch what's going to happen here. We're going to write this as a factored problem now, okay? And y'all have done this. We're going to factor it completely. So now we have x minus 3 times, what was left when we divided that out?
2x squared plus 3x 4.
Y'all all with me there? The question in the beginning was find all the zeros, right?
So now we have to simplify it all.
So x minus 3 could be 0. And this could be 0. Well, how could that be 0? I'm looking at this and I see a quadratic equal to 0. My first choice is to factor if I can, right? But what multiplies to 8 and adds to 3? Nothing. So, I have some options. Complete the square.
Quadratic formula.
Quadratic formula. Okay. Any of that to solve that quadratic, we can do at this point, right? Because we have a quadratic. Now,
Yeah, I don't.
opposite
Wait,
B.
listen, we know how to use the quadratic formula. Do the good C instead. Because
You want to do it? It's going to be nasty.
That's
I
fine.
just want to do a quadratic.
Yeah, just do quadratic.
It's going to be worse than the quadratic formula, but I'll do it.
No, it's so much easier. Yeah, but I don't know how to do quadratic formula.
Whoever wants to do
I don't
it
know
the
how
bad
to do
way.
quadratic formula.
All right, if I solve this by completing the square, I have to get rid of my leading coefficient, right? So I have x squared plus 3 over 2x plus 2. I just divided both sides by 2, essentially, is what I did. Okay? So now I need to know, does this make a perfect square trinomial or not? And it does not, right? So I'm going to move it to the other side. And this is where don't start getting confused on completing the square to change forms or completing the square to solve, okay? If you're completing the square to change forms, you're going to keep that bad C over there and you're going to add and subtract. If you're completing the square to solve, you're going to put your good C on both sides, okay? So to find my good C, remember it's B over 2 squared because this is a fraction. I told y'all this was nasty. I'm going to multiply by 1/2 and square it because they requested that we do it this way. So this would be 3/4 squared, which is 9 over 16. 9 over 16. I tried to tell y'all I would have done quadratic formula on this, but that's okay. It's hard enough when your middle term is an odd number, but when it's an odd fraction, you're really setting yourself up for a lot of work. But that's okay. All right, so I've got x plus 3/4 squared equals 9 over 16 minus 2 as a fraction. 23 over 16. Here's why you didn't see the other zeros on there. Remember there were supposed to be 3? The reason we didn't see 3, they're imaginary. So I got x plus 3/4 equals I squared 23 over 4. And now I can move that 3/4 over.
Why do we have
You could have.
I know, I got there and I was already done.
And you got the same thing, right?
Yeah.
But again, that just pulls everything back that we learned all these different methods. You use the one that suits the problem you're in. Look at what you're doing and decide what the best method is for you to use.
Just completing the square, I would really make it fun.
Because usually on the test, all the complete the square questions.
The thing that completing the square is the most useful for is putting in vertex form, in my opinion. And if you think, remember the quadratic formula is just a derivation of completing the square.
So if we were to put, like, vertex form, it would just be x plus 3 over 4 squared plus
23 over 16.
Okay.
All right, so there you go. There's 2 solutions plus 1. Now,
Wait, how do you know that that's 2 solutions?
plus or minus.
Oh, right.
All right, you may encounter some. We'll do this one instead. All right, let's say I have 2x to the 4th plus 5x cubed minus 18x squared minus 19x plus 42. Okay, you have, there's no way you can factor this, right? The directions are just to find all the zeros. That's it, all right? So what I want to do, your list of PRZs, right? So let's just list them here. PRZs. All right, we're going to take all these numbers divided by 1, then take all those numbers divided by 2. Yeah. You have a lot of PRZs. Mm-hmm. All right, so I'm going to start with 1, 2. How about 3? 4? No. 5? No. 6? 7? 8? No. 9? No. 10? No. 11? No. 12? No. 13? No. 14? And then 42. Now take all those numbers and divide them by 2. So you only need to worry about those odd numbers, right? Because the other ones are going to show back up. 1/2. 2 over 2 is 1. 3 over 2? 6 over 2 is already on there? Yes. 21 over 2. Oh, I forgot 7 over 2. But you got to show all your work. You got to do it algebraically. Use your calculator as a tool to help you where to start. But right. That's exactly right. All right, so let me show you how this happens. All right, so Eliza's already graphed it, and she said the calculator shows all 3 of the zeros that are there. You should actually get 4 here. All right, because it's a quartic, that's right. All right, so looking at this, remember these are possible rationals, so they do not include irrationals or imaginaries, okay? So Eliza, since you have graphed that, why don't you help us cheat a little bit and give us something to start with? -2. All right, if I try -2, drop it, because it's hot, just kidding. 40, 21, -42. Okay. So factored now, write it as 2 factors. x plus 2, 2x to the third plus x squared minus 20x plus 21. I still, remember, I want this to equal 0 and I want to solve. I still can't factor that. Even if I tried to group that, it's not going to work. This is what I like to call a double PRZ.
A double PRZ?
Because now I'm going to look at this one and I'm going to repeat this process again. Okay? This is a way to factor when you have no, you can factor the biggest polynomial in the world this way, if it'll factor. Okay? It won't group. I don't think it would, no. It won't group.
Wait, why can't you just take the other zeros and plug it in here?
Okay, so you could, but I want you to understand what it is we're doing. I want you to understand if you don't have a calculator, which you could be in the position at some point in here where you don't have a calculator and you have to know how to do it, then I would do PRZs of this one, the one that's underlined in pink, okay? So factors of 21, 1, 3, 7, 21. Now divide them all by what? 2. Now understand we're not just dividing by 2 because that's 2, that's just the factor. If that had 3 factors, we'd divide by all 3 of those, right? All the factors of the first one is what you're dividing by. So whatever those factors are is what you're going to divide by. It has, just because those are really easy ones to use as examples. If that first number had been a 4, we'd divide by 1, then 2, and then 4.
Wow, isn't that crazy? We ended with 21 over 2. Wow. Nah.
All right, so now I start picking these. Now remember, this could be a long process without a calculator, right? Without a calculator, I'd start at 1 and I'd start going there, or whatever you like to start with. Eliza, did you find another one that might be convenient for us to try at this point? Well, you don't have to, it's still going to be the same zeros. We're still finding 1.5, which is 3 over 2. I would never start with that if I were guessing. If I were plugging in and doing synthetic, because I can go much quicker with whole numbers, I would rule out the whole numbers first, right? So, and some of them might be imaginary, that's okay. So, is it positive or negative? Does it cross at positive 1.5 or negative 1.5? Positive. So remember, we want same sign for zeros, opposite sign for factors, right? All right, so this time I'm just doing 2, 1. What's wrong?
Wait, you said it was positive.
Yes, it would be
So
negative.
negative.
The factor would be x minus 3 over 2, but the 0 itself is 3 over 2.
That's where I'll probably.
Wait, what?
So make yourself a note because that is someplace where everybody messes up. This factor is x plus 2, right? We changed the sign. But if I asked you what the 0 is of this factor, it would be negative 2, right? We divide by the same sign of the 0, the opposite sign of the factor. Yeah, you might want to jot that down because that'll get you bogged down on your homework. We divide by the same sign of the 0, the opposite sign of the factor. Same sign of the 0, opposite sign of the factor.
So how did you know that, so the only reason why we knew that
Eliza graphed it.
is Eliza graphed it.
If she hadn't graphed it and I didn't have a calculator, I would start plugging in 1, then negative 1, then 3, then negative 3. I would anyway. Now, you might not. Maybe you just like to start with your fractions first. I don't because... All right, so 2, let's make sure it works here. 3 over 2 times 2 is 3. That makes 4. 6, negative 14, negative 21, and 0. Okay, so understand what that means. The x plus 2 is still out there, right? Now I've got an x minus 3 over 2. Now, praise the Lord, I have a quadratic. And I know that no matter what, I can work with a quadratic.
The quadratic
The first thing that I notice before I do anything else, yeah.
Can you write that x minus 3 as 2x minus
Yes, you can. Yes. Well, before I do that, I'm going to take a 2 out of everybody. It's going to make my factoring life easier. Remember that? We always want to look for that GCF. And I'm just going to stick it out. Remember, multiplication is commutative. I can do it in any order. So if I throw it in the front of the equation, that's perfectly okay. X plus 2, x minus 3 over 2. Now my quadratic is a little bit easier to work with. So now the question becomes, does anything multiply to -7 but add to 2? Not only is this a double PRZ problem, it's also a quadratic formula problem. So this thing has 4 zeros, -2, 3 over 2. And then opposite b plus or minus square root of b squared minus 4ac. See why I made you remember that quadratic formula? 2a. 4 plus 28, 32. Oh, I'm going to be able to simplify this, y'all. You're not going to like that. Right? I can take a 4 out. Actually, 16.
Yeah.
Oh, inside of the.
Yes, you can after, but it's going to have to come out of this radical part one too.
So we simplify last.
So divide everything last, because if that coefficient hadn't been in front of that radical, I wouldn't want to divide all the pieces by 2 like that without splitting them up. So here, this is going to become...
You're not dividing inside the...
No, not there, on the outside.